The previous video looked at what e to the x looks like, but what if we have just a random exponential function like f of x equals 3 times 2 to the negative 2x plus 7. We know it's exponential because the only interesting thing about it is that there's a variable in the exponent, and it's worth reminding you that exponential functions are repeated multiplication. So how do we find these different things? From the equation, what we will do to find the asymptote is set the entire exponential part equal to 0. And this is not saying set one of the variables equal to 0. It pretends that the whole exponential piece becomes 0. What happens? For the y-intercept, that's setting x equal to 0. For the domain for all exponential functions is going to be all real numbers, but the range will not. The range is either going to be y is greater than the asymptote, or y is less than the asymptote. It's not going to be both of these at the same time. It's just going to be one or the other. So sometimes you will have, usually you'll have something like, here's our asymptote, and it's going above, but occasionally you'll have something like, here's our asymptote, and it's going below. And you can just plug in any value or look at the y-intercept, and you'll be able to tell, are all the points above the asymptote, or are all the points below the asymptote? Based on that, you'll be able to tell whether the range is y is greater than or y is less than. And for growth versus decay, you want to look at, look at the base of the exponential function. So if we have something like 2 to the x, that's going to be growth. Whereas if we have something like 1/2 to the x, because this is smaller than 1, it's going to become smaller and smaller every time we raise it to a larger and larger power. So this would be decay. Now, the trick comes when we start having a negative exponent, because if we have, say, 2 to the negative x, hopefully you agree with me that this is the same thing as 1/2 to the x. The long way of writing that is by saying, okay, this is 2 to the negative 1 to the x by our exponent rules, and then this is 1/2 to the x. So if the exponent is negative and you have something that looks like growth otherwise, it will be decay. And similarly, if we have something that is 1/2 to, say, the negative 3x, this is the same thing as 1/2 to the negative 3rd to the x, which is the same thing as 8 to the x, which is not decay, but growth. So once again, when you simplify it, is the base bigger than 1? If the base is bigger than 1, it's growth. If the base is smaller than 1, you're going to be repeatedly multiplying by smaller and smaller numbers, and that is decay. So let's analyze an actual equation. So let's see. The asymptote. So what I said was set the whole exponential part equal to 0. So we have 3. The whole exponential part, I'm going to say, is 0. I'm not setting a variable equal to 0. It's just when the exponential piece isn't doing anything. Well, then this will be 0 plus 7. So y equals 7 is our asymptote. This is because this will never actually be 0, but as it gets closer and closer to 0, then the whole function gets closer and closer to 7. The y-intercept, we plug in 0 for x, so 3 times 2 to the negative 2 to 0. This is 3 times 2 to the 0 plus 7, or 3 plus 7, so 10 is our y-intercept. So 0, 10 is our y-intercept. The domain, all real numbers. The range might not be obvious. It's either going to be y is greater than 7 or y is less than 7. How do we tell? Well, there are a number of ways to tell. The easiest one, once we've found the y-intercept, is to say, oh, the y-intercept is bigger than this. So if I were to graph this, it would look like we have somewhere at 7, we have an asymptote, and one of the points, the y-intercept, is bigger than it. So it's going to have to be y is bigger than 7. If the asymptote were still 7, but we had like 0, 2, then we'd say y is less than 7. And lastly, is this growth or decay? So this is the case where we have 2 to the negative 2x. Because we look at 2 to the negative 2, that's the same thing as 1/4 to the x, so that is why it's decay. So a good sketch of this graph is going to be, all right, we have this asymptote at y equals 7, we have an intercept at 0, 10, and then we know that it's decay. If I ask you to graph this, not sketch it, you should be more specific about it being multiplied by 1/4 every time we go to the right. But this is a good sketch. Thanks.